Yes,
Yes.
success.
I'll just do a quick intro to Steve. Steve's going to do the quad chart and one more slide. This is a deep collaboration with Internet 2 that we actually started last year, which gave us the idea that this could be operationalized into something that really fits the CIC program really well. So Steve, take it away.
I had to share my whole screen. Can you guys see the slide okay?
Yep, perfect.
Yes, we got it.
Good. Okay, so I have a cheat slide in here. Here's our quad slide. Basically, the goal of this project is to improve the routing security of the global research and education network infrastructure. That infrastructure is pretty pervasive. So there are about 2,700 autonomous systems in about 110 countries that make up what we call the global R&E network infrastructure. And that infrastructure lags a bit the rest of the internet in terms of certain routing security metrics. And it also is sort of by design particularly vulnerable to certain routing leaks that happen from time to time. So one of the differences this network has is most users of this network prefer this network as the path to reach another institution that's also connected to this common infrastructure. And that kind of routing policy is different than the routing policies that you would typically apply to your other, like your commodity internet connections. And it leaves you in a vulnerable space. So for example, if a network, let's say in Latin America, leaks a route to Amazon into this infrastructure, and that's propagated throughout this global infrastructure, that everyone in this infrastructure is going to prefer that route to get to Amazon, even if that doesn't make any sense. And we see these kinds of route leaks cause this type of disruption periodically. We've designed a system that we initially designed a system that uses active probes to determine the routing policy of all of these networks. In other words, first of all, we developed a system initially to identify when networks that are part of the global R&E infrastructure actively choose routes from that infrastructure over routes that they would receive from other networks. And we don't look at routing tables for this. We actually do active probing, and we're adapting that system, that measurement system, to detect leaks for routes that leak from the R&E infrastructure into the commodity infrastructure. And then we're looking at other approaches to both detect leaks from the commodity infrastructure into the R&E infrastructure, as well as provide a resource for network operators like Internet 2, which is essentially a curated list of routes that represent routes that are genuinely part of this infrastructure. So part of the routing security controls that you can put in place is doing route filtering. So we plan to do that and maintain an object in an internet routing registry that Internet 2 would use, but other networks could use as well. So just the sort of touch on the main things we're going to be doing through this project: detect route leaks between R&E and commodity networks, identify misconfigurations that divert scientific traffic off of R&E paths. So we will have the ability to tell when particular networks are configured such that their traffic intended for another R&E destination is actually not going to take the R&E path. And again, classify and validate prefixes and maintain an authoritative complete list of R&E routes. We'll integrate those measurements and analysis into an operational dashboard. So Internet 2 currently hosts a dashboard that provides a BGP route report for all networks that are connected to Internet 2. And through this project, we're going to expand the scope of that dashboard to include the set of international networks that make up the global R&E environment. And we're going to go and we're going to enhance what the dashboard provides to users We're also going to add a visualization of the RNA AS topology. So as I said, there are about 2,700 networks in 110 countries that make up this environment. And there are other projects in other parts of our community providing sort of a physical map of how these networks interconnect, but we're going to provide a BGP map that shows how these networks interconnect today. It's also the case that there's a slower adoption for a variety of reasons of an important emerging routing security feature. These are called RPKI ROAs, and essentially they're relatively easy to create, but sometimes they're difficult to plan. And we're going to be developing an online tool that will aid anyone in our community, and actually it'll provide the same capability to anyone who operates a network that's part of the internet to plan how to create their ROAs. Creating a ROA is just simply filling out a web form, but if you fill it out incorrectly, you can cause your internet connection to go down. So it's important to do it correctly, and sometimes they're a little complicated. So we're providing a tool that will help people plan their ROAs, and also if they have a ROA, validate it's correct before they actually put it in place. So we're going to have good information about route leaks, routes that should be part of this global environment. We're going to have tools to make that information available, help people with ROAs, but we're going to need to do some significant community engagement to get people familiar with these tools, to assist them with using the dashboard and the ROA planner. And we also want to measure how these metrics are being adopted by the community. We want to make sure these tools are also readily available to all of the NREDs, all the National Research and Education Networks, in addition to the regional networks here in the US. And we hope this ensures that these workflows stay on this dedicated infrastructure. We have a paper accepted at the upcoming Internet Measurement Conference that talks about a significant portion of this infrastructure is configured today such that it does not ensure that these flows stay on this infrastructure. And we hope that these tools and our outreach can greatly improve that, and also ensure that the infrastructure is resilient as it can be, and certainly as resilient as the commodity infrastructure. And again, there's certain metrics that we're lagging that infrastructure in today.
This is awesome. Right.
We're at 8 minutes already, Steve. So, you're not going to do the third slide. I was going to say, yeah, let's.
Sorry.
No, that's great. So this is I think this is going to be a really impactful thing. I mean, so if I ask the previous two talks to kind of switch from your data collection hat to your operations hat, right? I think this is something that AmLight would care a lot about, and Delta AI should be wondering about, like, am I actually using Internet 2 or appropriate networks to get there? So Casey and Steve, I think of this more as sort of a real-time benefit, the dashboard and that, than a longer-term background data. But I don't know, what do you guys think in terms of data? Not everything has to be long-term data collection, but I think for me the value here is really a day-to-day operations that I hope is part of the operations of basically every RAN. I don't know, where's the data fit, I guess, right? Or does it?
So there are a couple of things. One is we want to keep some longitudinal data on the adoption of these practices. Okay. And I know that's probably not a lot of data, but it's important data to measure what's working and what's not working. We also want to have a better measurement of incidents that occur that are related, especially related to route leaks or route hijacks. There is our active probe measurements. Again, not a lot of data, But I think those are important that we capture and provide as input to sort of the next generation of those tools. And then there's some simple things like observing how and who are using the data through the portal.
Excellent. Yes. So, so for the OSDF and NDP teams, right, we're giving you a flavor of a lot of different things here. Yeah.
As a quick question to also switch from maybe data sets, but since we run an infrastructure and run distributed services, obviously a lot of things about routing are really focused on RENs, but would it, do you see possibility of having interest in, looking at routes to say endpoints within the OSDF? Do you think it's limited, the value is limited to RENs, or is there also value for us running services?
So if those services are running in one of the 2,700 networks that make up the global R&E infrastructure, so that means if it's running on a campus or a research and education network in the US or abroad, we're going to be measuring the routing policy of those networks and their adherence to standard routing security stuff. If it's outside of that, and it makes sense for us to, there's some limitation. Our ability to look at, we're using something that's novel to detect leaks. We're not using the normal tools. And typically, if you're looking for route leaks, you're trying to monitor the routing tables of a bunch of networks. We can actually detect route leaks even for networks that don't share their data with route views or RIS or anyone else. But we can only measure those if they're part of this infrastructure. And we use a simple trick. We have an active probe that probes endpoints in these networks. And then we look for, how did the packet return? Did it return over this infrastructure, or did it return over the commodity infrastructure? And so that gives us a unique way to tell whether there have been route leaks and how things are configured. But if there's infrastructure outside of this, we'd be happy to entertain a conversation to see what we can do.
So the question is, in a combination of OSDF and the OS pool, we use capacity at 80 national institutions and probably another equal number of international institutions where we move stuff and control the movement between the endpoints. Would this kind of traffic that we generate, or we can generate it for you, be useful for your monitoring? That is, I don't know, but.
So the data we consume, we do consume routing data, but we generate the active measurement data we actually generate from these multi-homed probes. But in terms of characterizing the networks that host your endpoints and their adherence to routing security and how they're routing their packets, we can see that with or without your traffic.
I see.
So let me kind of say that, okay, I think we've kind of got the ball rolling in this one as well. I think there's some interesting follow-up here, not just on the data stuff, but on the operational aspects of this. Whether you're whether you're an HBCU or a OSDF data platform, this could be potentially interesting.